Any of our source properties can be set by either double clicking to open up the source menu, right clicking and using the edit menu, or selecting the object and pressing F2 on the keyboard. Depending on the type of source we have selected, the options that you will see here on the source properties will vary. Here on this three-phase source, we can see that we can set our phase neutral and our phase voltage. We can set the type of earthing system, TN, TT and IT. With TN system selected, we can also set a subcategory of TNCS or TNS. The supply frequency of our system can be set to 50 or 60 Hz. To the right hand side of these options, we are able to also then set what the voltage drop limit for our system is going to be. As per the standards within the regulation, we can set this to be as a public supply or a private supply, and we can also set a user-defined limit where that is necessary. In the next area below, we can select a method of supply. Here we can set from a number of preset systems within the software. User-defined source is the default setting, which will always be automatically selected by the software. Transformers or generators. Here, if I select the transformer option, you will see that a new tab will appear. This is allowing us to provide information about the high voltage side of our system. You will also see that a number of the source characteristics have also changed to give more information about the transformer in order to calculate our fault currents. On the generator, we can see that the options here for the source characteristics have also changed relevant to generator type systems. Going back to our transformer settings, any of the settings that we place here can be used to calculate then our load capacity, and then the software will use that data to calculate what our fault currents will be for our source of our system. Here, if I set this to a 1500 kVA transformer and calculate the fault, you will see that the load capacity has increased and our fault calculations have also been corrected for the source characteristics that we have input. If you have specific information from the manufacturer in terms of the fault current levels of the transformer, these can also manually be placed in here rather than having the software calculate them for you. Selecting any particular box, we can change the data directly, and as you will see, it will automatically update the other information in the relevant fields. The software also will identify power factor from the IEC standard 609472. Here I have now inserted a single phase supply. Going into the circuit edit, we can see how the information now has changed for our source properties. Being a single phase source, we can now select which phase the source is being supplied from, the phase neutral voltage, and the relevant earthing system as discussed before. The other options below for the method supply are the same as before. However, we can only see our fault calculations for phase to neutral. Here we have our DC battery supply. Going into the source options, here we can see the options available for the voltage of the battery system, the earthing system, the particulars for the source characteristics, which can then be used to calculate the short circuit current of the DC system. Again, the short circuit current can manually be inputted in order to match any source characteristics that you have predefined.